Okay, this is the November 2020 paper 2 question on electrolytic cells. It's question 9. It says the simplified diagram below represents an electrolytic cell used to electroplate a copper coin. Here's our copper coin with silver, and here is my silver electrode on the other side. Okay, it says define the term electrolysis. Well, electrolysis, learn your definitions. It is the chemical process in which electrical energy is converted to chemical energy. So basically what you are trying to do is you are trying to use a battery or a DC power supply to create a chemical reaction. And in this case, it's a redox reaction. It says which component in the diagram indicates that this is an electrolytic cell? Well, it is this, the battery. And if it's not the battery, it is some kind of a DC power source. Because remember, we are wanting to put in energy, and it must be direct current electrical energy. Now it says write down the name or formula of the electrolyte. So obviously the electrolyte is this thing in the solution here. They've even labeled it for you. So when we want to figure out what's the electrolyte, we actually have to figure out what are we trying to do. And in this situation, we are trying to put a layer of nice expensive silver on top of our nice cheap copper. So how do we do that? You have to have silver ions in solution that get attracted to this electrode, because this electrode will be the negative electrode. Okay, look at the battery here. This side is going to be negative. This side is going to be positive based on the way the battery is drawn. So all of my positive ions in solution are going to be forced to this negative side, where they will be given electrons and they will undergo a chemical change. And what happens is the silver ions in solution become solid silver on the coin. So when we talk about the electrolyte, we have to talk about something that has got a silver ion in it. And obviously we don't want to spend a lot of money melting a silver salt. So we need a silver salt that is soluble in solution, and all nitrates are soluble. So silver nitrate is the most commonly used salt for doing this. Otherwise, you have to find some other salt that all of the salts are soluble. So silver nitrate is the most obvious one, but according to the memo, you can have silver ethanoate and silver fluoride and silver perchlorate. If you wrote silver chloride, no. Remember all of those tests from grade 10. How do you test for chloride ions? You add silver nitrate. So you just need some kind of a soluble silver salt. All electrolytes are a soluble salt of whatever you are electroplating with. Now it says, how will the concentration of the electrolyte change during electroplating? Choose from increase, decrease, or remain the same. It is going to remain the same. Why will it remain the same? You say to yourself, I am putting all of my little silver ions over to the copper coin and they are plating it. They are going out of solution. Surely my concentration of silver ions should decrease. And yes, you would think that, but that is the whole reason for this lovely electrode over here. Can you see this lovely silver electrode over here? This silver electrode is now returning the silver ions into solution, because here the silver metal loses electrons and becomes silver ions in solution. So the concentration of the electrolyte stays the same during electroplating. What is the reason? Okay, the reason is because the rate of oxidation, okay, where is the oxidation occurring? At the anode, and this is the silver ions going to silver metal. Okay, the rate of oxidation at the anode is the same as the rate of reduction at the cathode. What does this actually mean? This actually means that for every silver atom on this side that goes to a silver ion, the electron that is removed travels through the circuit, comes onto the other side, and meets a silver ion, and here the silver ion becomes silver metal via this little electron pump that we call the battery. The battery is moving the electron pump, and then in the solution the ions are moving in the solution so that the circuit is completed. So it says to you, write down the balanced equation of the half reaction that takes place at the silver electrode. The silver electrode is the anode. It is being oxidized. Its mass will decrease, okay, and we know it's the anode because it's connected to the positive terminal of the battery. So we write the reaction Ag goes to Ag plus an electron. Now, if you are not sure about how to write this reaction, if it's got a 1 ion or 2 ions, or you're not actually sure, you go to your table, okay, and you look for silver in your table. So here in the table is the reaction we are looking for. This Ag plus an electron goes to Ag. But remember, this is my reduction reaction, okay, and we are asking what's happening at the oxidation electrode, okay, so we have to reduce the reaction. Ag goes to Ag plus an electron, and that will now be the appropriate reaction for the silver electrode, because the silver electrode is the anode. And that is the end of the question, which is relatively easy.